Yeah, this is the project. Okay, so why don't you go ahead and go into, so try to understand the project. Can you run the tests?
Yeah. All right, let me move the terminals here. So yarn test. To pass. Okay.
Okay, so what does this project do? Do you know what this project does?
Not really. Yeah, that's the first time I clone it. Maybe you can give me a quick
Yeah,
overview.
so basically what this project does is allow you to kind of simulate CosmWasm in your browser in a JavaScript environment rather than, having to run a REST client and do whatever. So it allows you to take WASM bytecode and then, send it messages, and then get back what would be the results and like sort of invoke each of the or execute some of the functions, right? So if you look at the test code down there, right, what is it doing? Right. So first we need to mock like an environment, contract, right, info. And what it does is it kind of, create something, like it instantiates something, and then you're able to execute against it, et cetera, et cetera.
I see. Okay, so it's similar to, let me show if you go to like either scan and if search for like random address, let's search for this one address. And if you go to, where is it? No, nice one. Yeah. Let me go to one of the address.
You need to go into like a contract.
Yeah, I'm
but
looking
it's
for contract.
it's not exactly like that.
Okay.
So that one allows you to query against it, which invokes a blockchain. But here we just have the VM. There's no chain, right? There's just a WASM. So it basically allows you to run, let's say like CosmWasm in your browser.
So it's basically a sandbox a sandbox basically.
Sure, you can call it like that, but it's mostly just the using WASM VM. How do you interact with CosmWasm using like JavaScript? How do we just pass in JavaScript objects and then get like executed using the VM, and then how do we get something out, right?
So without the chain, like when we call this function, like for example, instantiate, execute, and all that, where does it talk to? Like where does it store the state?
So how it works on the chain is it gets past handlers to interact with the blockchain, right? So rather than passing those handlers in, we swap them out for something like a store. As you can see, like we gave it a key value store, right? Right now it's just a map from string to string, right? So this allows us to kind of simulate its access to the blockchain store. Rather than being the blockchain store, it is directly, the key value store. Look at, for example, memory is, how can you, I have some classes here that basically wrap around like a region. So, what is like a region of memory? To understand this, I think you should clone CosmWasm project in Rust. Just go to CosmWasm. Yeah. Yes. Yeah. Just clone it.
Oh shit, not in here. All right, CosmWasm. So there's contracts. Where should I look at?
You should probably look at, I think it's some, not contracts, packages. VM and wait, hold on. Instance.rs. instance.rs. Okay, so this looks a little bit complicated, right? But if you keep going down, you know how it sets up so what it does is it's in setting up an instance with these certain functions, right? It's called abort, db scan, db next, go above, go up. Yeah, these are basically we call something called WASM imports, right? So what a WASM import is WASM by itself doesn't really have anything except for executing things like manipulation of memory, arithmetic, right? So what we do is we provide hooks. We load the host with something called an import, a WASM import, which the executing program is able to call. It's like a system call, right? In Linux or whatever, and that basically allows it to access these functions, right? So if you look at the signatures for each of them, go to, for example, do db write, all the way up, do db write, right? Yeah, try to go to it.
It doesn't allow
or
me to go.
find it some pub fun db write. Okay, so what is it taking in? It takes an environment key
Key, okay, the value.
right? So this key pointer is actually a pointer to something called the region, right?
Yeah.
So if you go to this thing, it says let key equals to read region and memory key pointer and then max db key length or whatever, right? So what is read region? Right, what does read region give you back?
So it's return the key and value of that.
Yeah,
and
go find read region. Go find the definition of read region. Pub fun.
Yeah.
Right. So you take in like a memory, which is like basically a long WASM memory, which is a contiguous like byte array, and then the pointer, which is the index in the byte array, and then the size, right?
Yeah.
Right. So then the output of it is VM result vec_u8. Vec_u8 is a vector of bytes, right?
Yep.
Right. Right. So then it's
okay. So basically, okay, I see. So we like for I remember using this hold on, instant. Yeah, I remember using this method in the CosmWasm contract. So that's how we like adding.
yeah. So that's how we inject new functionality, for example,
Right.
into like CosmWasm VM, right?
Makes sense.
Because by itself it cannot interact with the chain. We need to provide the hooks, aka like system calls or aka WASM imports, such that the WASM can trigger these functions that are supplied to it and then execute functionality that is beyond WASM, right? So how we do this, basically we need to set this up. We need to set up the VM with this hook. So what we do is we create a alternative sort of instance, right? And we create like sort of the simulation of the stuff that it would interact with. Like each of these functions we have to provide analogs for, and then for example, it interacts with the store. Instead of interacting with the store, we might interact with a class that manages a key value. Here's something like a map from string to string. Right.
Sorry, give me 1 second. Someone ring the doorbell. I'll be right back.
Sure.
Yeah. I'm back.
Okay, welcome back.
Thanks. What's for dinner?
Right. Nothing. Yeah. All right. Where were we? We're talking about.
Yeah, so we're talking about the hook. So we
Right.
yeah.
So this thing hooks into the blockchain. We hook into the JavaScript class that emulates the functions of the blockchain. For example, we might want to instrument VM operations. We might want to instrument data access, right? Or we might want to make a visual version of the blockchain state for debugging. All of that is potentially useful, right?
So so it's similar to like rewriting this CosmWasm in JavaScript.
No,
Some
because
part, basically we want to rewrite some part
we
of
want
this.
to so JavaScript already has a WebAssembly runtime. So all we have to do is we need to set up the imports, WASM imports, as you can see here, right? We need such that when we execute our WASM, we need to be able to pretend like it's in the environment that it thinks it's in, right?
Okay.
Right. So go ahead and take a look at the code again, and notice. Right. So maybe what you can do is write those functions like the secp 256k recover pub key. Maybe you can implement those imports, because if you go to back to the code with if you go back to code with our memory, right? As you can see that I've kind of made a version of this thing. It takes it's a region, right? The region kind of points to another data object called a region, which has something called capacity, length, and offset, right? So this thing is what you use to kind of manage sort of the memory. And
Okay.
yeah, I mean, if you go into the if you go to the vm.ts, it kind of shows you how it works. So what it does, it basically passes in JSON and then puts that in memory. So
I see. Okay. So we getting all the information and allocate the JSON right here. So what's
right. So for example, this that exports. What is exports? Right.
So JSON, wait. This instant of exports.
Yeah, because when you create a like CosmWasm like binary, you kind of have something called WASM exports, which are the functions that are exposed, which are instantiate, execute, query, blah blah blah, right?
Yeah.
So we call those exports. So basically, when we get let instantiate equals to this at exports, we get a function, right?
Yeah. Yep.
And then how do we get the arguments? The arguments get passed into this function, right? But they exist as JSON, right? So what we do is we take that information, we allocate JSON, which means we call the allocate function inside the WASM. The WASM has something called allocate, so it allocates some memory inside the WASM, and then writes the JSON string, right? And then once we get, so we save that pointer to the newly allocated region of memory.
Yeah.
And then we pass that back into instantiate.
I see. Okay.
Right. So if you can see in instantiate, they actually get passed, pointers to each section of the arguments.
Yep.
Yeah. And then we get and then we create a region around the result, right? Because the result will also be written to memory. Cool. Right. So it's all using the same like signature.
Yep. Okay. Cool.
Okay. So as you can see, these are sort of the WASM imports, right? Like most of them are not implemented. The ones that I've implemented are the simple like do db blah blah blah.
Let me see. So let's do remove. with DB remove, right?
Okay, so yeah,
Okay, so basically just deleting from the
yeah.
store.
So what I want you to, so actually this is kind of sloppy because it's not separating the store. You can actually pass in, you should pass in any store with a certain interface, like a store interface, and it should work, but this one doesn't. So let's kind of extract that into an interface later. But right now, can you just follow what I did and fill out this prototype with the other
Import.
WASM imports? Yes.
Okay. Yeah, sure. I can look into that. It's not much, right? It's DB next, DB scan. Okay.
They might be complicated, so you might have to look at JavaScript functionality that provides that. And you also need to remember this cannot be async. So
Okay.
there's and there so try to do them all and find out the ones that are kind of difficult. Yeah.
Let me take one example. Did you do abort?
No, board is new.
Okay, not yet. All right.
Yep.
So let me
And then
just
also try testing with a new version 1.0 binary, like because currently CosmWasm is 1.0. This one was made with 1.13.
Mhm.
Right. Yeah. But if you do this, it should give you a pretty good understanding of how CosmWasm works, right?
Yep.
Right.
Cosm.
Because so one thing we need to do later is kind of separate out the VM with the store with like the gas, and then also a chain, like a sort of chain thing, because right now it's kind of weird how they've decided to sort of mix everything together. We kind of have to follow their thing because we need to calculate gas, and gas is sort of calculated here. So we have to kind of
Yep.
figure out how to calculate gas. Right now, everything is kind of mixed into this one class called CosmWasm VM. In reality, it should be different, but I can help you with the implementation details on how to separate things out. But or I could do that part. But I think right now what will be helpful is
Mm.
writing some tests for each of the WASM imports.
Yep.
Make sure that the imports match up.
Sounds good. Awesome. Imports. Wait, so you said you want me to test with the latest version of the CosmWasm, right?
Well, yeah. So kind of build like a test contract.
So it's
Um,
version 1 right now, just the latest one.
yeah. No. Like when you create, I think if you create new CosmWasm contracts, how about so what we want to do is we want to build like a sort of testing contract that calls a certain
Oh yeah.
like yeah
Okay.
like calls a certain WASM import. Yeah.
Cool. Cool. Yeah, that makes sense.
Cool. I think a lot of the prior work was already figured out using the region pointer. That was pretty much the hardest part, like figuring out how the region memory works.
Yeah.
So just use the memory.ts abstraction, or
So
just like that.
all right. So what about the store? Do we want to change that or we just want to
Um, no, let's just keep it as a map from string to string for now.
mm,
Later we're gonna generalize it to work with any database, right?
cool. So let me package source instant. All right.
Mhm.
So putting all the nodes so I don't forget. All right, so implement all the CosmWasm imports. Import can be asynchronous, it has to be synchronous. Test with the latest version of the CosmWasm contract.
Mhm.
And write tests for the WASM imports.
Mhm. Right.
Anything else?
No.
So all the imports should be in this file, right? Instant.is and any other places?
No. just put that in which one?
No, I mean like the CosmWasm imports. It's in this single file, right? It's not like separate by an instant or something else.
Yes, I think so.
Okay, cool.
Yeah.
Oh,
Cool. And then you can kind of get inspiration. For example, let's look at do DB right. The definition of do DB right.
mhm.
I think it's you have to search. Okay, look at it.
Okay,
Right.
so
This-
basically check if the environment read
Mhm.
only. Okay, so if it read only access denied, that makes sense. And then we read the region for the key and value, and then return the result with the gas info.
Okay, so no, we don't return gas info.
Mhm.
But this basically processes the gas. The gas is actually supposed to be tracked in the env, but here we don't have the env yet. So
So in the JavaScript version, should I look into implementing the gas information?
not yet. No, wait for me for
Okay.
that.
Okay,
Yeah,
cool.
I think I mean, I'm not sure you can figure out right now, right just yet. It's quite a bit convoluted. So
Yeah.
let's ignore the gas information and add the gas later because it's in the you need to create a struct called gas info, and then that is tracked also a bit weirdly, which is also in the environment with storage from. So if you look at this, right, look at the do db right, go all the way up, do db right. No, the good pub fun, the implementation all the way up. Yep. Okay.
Yep, right here.
Okay. Do you see where's the actual code that does the thing? Where's the code that execute? No, this is just reading. Right. So
So
here we
set it, right? Store
yeah,
set.
exactly, right. Cool.
Oh,
So we just need to supply like what is store and what and how it gets set. Mhm.
okay. So I think so this one is like similar to like building a memory model for storing the contract, right?
Yeah.
Okay.
But for that we're using the key value store of string to string, and then we store the like I don't know. Let's use the UTF-8 encoding of bytes
Yeah.
or base 64.
So what's the use case for the CosmWasm JS? Like who's gonna use that? Are we building like a front end on top of that
Yeah, we're
eventually?
gonna build. We're probably it's very useful for testing, right? Because imagine
Yeah.
right now you have to test using CosmWasm in Rust. You have to test using CosmWasm in so what it allows us to do is build like stuff like debuggers, stuff that we can trace the memory, stop the execution whenever we want, right? Because you can think we can instrument not only the like DB store, but we can also instrument the VM itself by wrapping like doing a hook every time it's calling this do DB write whatever, and then we can use it to like visualize every time like something gets hit and find the code path that leads to it.
Okay. Cool.
Mhm.
Sounds good.
Cool. All right.
All right. Anything else you want to go over?
No, that'd be it. Thank you.
Cool. Thanks. Thanks, man.
Yeah. Be sure to ask me a lot of questions.
Yeah, I will.
Okay. Bye.